Welcome. In this video I'm going to show you how you can analyze a single ordinal variable using Python and specifically with my stikpetP library. This video will focus on how to generate the output you need and not so much on how to interpret that output. I will be going over generating a frequency table, then creating a visualization, use the median and a measure called consensus for dispersion, then a one sample Wilcoxon signed rank test, and add as an effect size measure a Rosenthal correlation coefficient. I'll quickly show you also some alternatives, and let's dive in. First we'll need the stikpetP library. This is not available via your basic pip install, so you'll have to use download it directly from my GitHub account and then install it from there. So if you uncomment this, it should work. I have of course already installed it myself, so I only need to then import it, and now everything should work. I'm also going to be using an example file, so I'm going to use pandas and then load my example data that's available on my website, so I can use a read CSV. Then we need a specific field from this data set. So in this case I'm using the teacher motivate, which was about if the teacher was able to motivate the students. And it had actually as options fully disagree, neutral, agree, and fully agree. So I'm also using the codes for those. Then to get a quick first impression, we can generate a frequency table using the tab frequency function. If you click on these links, I'll leave a link to this notebook in the description below. Then it will actually show you the help files for it, and this will be the result in this case. As you can see, quite a lot of students actually disagreed, 12 were neutral, and only a few actually agreed. There's a difference between percent and valid percent. Percent includes the missing values, so if you add up these, they won't add up to 100%, and the missing part are the students who didn't answer this question. As we can also see is that 54% about already disagrees or fully disagrees, 76% has neutral or disagree, and let's say disagree is worse in this case. We could also visualize these results by creating a stacked bar chart. This link should actually be to the stack bar chart. I'll adjust it later. And as you can see here, this is the function. We give it the text data and the coding. If you have already numbers, then you can just use the data and you don't need to specify the coding. And it simply generates a very basic stacked bar chart. Here we see a similar result. We can see that just over 50% is in the disagree part. Neutral fills up a quite big part, and only a few actually agreed or even fully agreed. To actually find the center, we could have a look here at 50%, which is where the median should be. So it's probably going to be just at disagree, but you can use ME median. Use the codes again, and in this case we then get 2 is the median, which corresponds to disagree. We can also have a measure of dispersion. I came across one that was labeled as consensus, so there are not that many. Many will actually use something like the interquartile range, but if you have a Likert scale with only 5 options, quartiles might not be so worthwhile of using. So this was kind of nice. In this case it turns out to be 0.4289. We want probably to test if the middle option is indeed significantly different from the neutral option. So if you leave the test blank, in this case a Wilcoxon signed rank test for one sample, it will actually use the middle option that you have. So in this case we had 5 options, so the middle would be 3, and use that as its test statistic, or its value according to the null hypothesis, if you will. The test will actually show you quite a lot of output. The most important one is the p-value, on SPSS often referred to as the significance value. This is just below or quite below 0.05, so there's an extra 0 there, so and that's usually the threshold. So it means in this case it's significantly different than the 3 that was actually tested, so the neutral option. So indeed a significant proportion found that the teacher wasn't able to motivate them. There is an effect size measure called correlation coefficient, but then for specifically these kind of tests where you have a Z value, I call that the Rosenthal correlation because the most famous correlation is the Pearson correlation, and I couldn't really find an alternative name for this one. It's basically the Z value divided by the square root of the number of items. So we can obtain the number of items from our test results, which was that 42, the number of ranks that were actually used. The Z value that was calculated from us is the statistic, so we can actually also obtain that. And then we can just feed those two into that function, and it gives 0.43. We could perhaps interpret this similar as a Pearson correlation coefficient. So in that case, you can use the rules of thumb for that, and that will give you that it's a moderate result according to this reference. Alright, and that should give you all the information you need to analyze a single ordinal variable. There are quite a few alternatives, of course. So for example, for the visualization, you could use a dual axis bar chart. It's the same as a regular bar chart, but then it adds the cumulative percentages on the right hand side and as a line graph. So it's almost like a Pareto chart. Alternative measures could be those quartiles. As mentioned earlier, if you only have a few options like a Likert scale, they might not be so worthwhile, but alright, in this case it's 1 and 3, so it's at 25% and 75%. There are quite a lot of ways of actually calculating these. If you look into the details of this function, you can see that you can actually select quite a lot of different versions of it. Based on those quartiles, there are a different few types of ranges. So there is the interquartile range, IQR. There is the semi-interquartile range. You have the quartile deviation, which, if I'm not mistaken, is actually the same. And you have the mid-quartile range, and all three can just be found by using the quartile range function and then select the measure that you want. A few different tests. There's the sign test, which simply looks at how many were there below the hypothesized value and how many above, and then performs a binomial test on that. Looking at a trinomial test, that actually then also looks at the number of scores that were equal to the hypothesized value. So especially if you only had a few options to begin with and a lot of ties, this might actually be preferred. And that can be done with a trinomial OS. Alternative effect sizes, there's rank by serial for one sample. And there's something known as a dominance score, which can also be, of course, obtained by using my package and the dominant effect size. And that same site where I got this information from also reports a so-called VDA-like measure, so I also included it in there. Alright, and that's how you can get quite a lot of these different options for analyzing an ordinal variable using my library. Again, on my website I explain more in detail on how to read this kind of output and some more details on each of the things mentioned here, and this was just mainly about how to get the output. I hope this was helpful, and thank you for watching.